This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at this eye contact feature from NVIDIA Maxine. Okay, so what is NVIDIA Maxine? NVIDIA Maxine is a suite of GPU accelerated AI SDKs and cloud native microservices for deploying AI features which can enhance audio, video and AR effects in real time. Okay, so let's go to what is this eye contact feature, right? So here is this video which is present over here, which explains about eye contact. So let me just zoom out over here. So basically over here, if you see eye contact off, okay, so basically when a person is having a video conference and when this eye contact is off and the person is looking away from the camera, it comes like this, right? But with eye contact on, this feature enabled, what happens over here is that it actually generates and video where it seems as if the person is looking at the camera. Okay, that is the whole idea over here, right?
The latest improvements deliver better accuracy, blink animation, eye tracking, and ease of integration for all your applications.
Okay, so that is what they have explained over here.
Or bring up your next slide deck. Studies have shown that maintaining eye contact
what they're saying
during
is that
conversation encourages.
If eye contact is maintained throughout the conversation, it encourages and improves productivity. That is what they claim over here. Okay. So the key features here is that they have face expression estimation, tracks the face and infers the subject's expression. Okay. Then eye contact, this is the one which I was talking about, simulates eye contact by estimating and aligning gaze with the camera. Okay, so they have an updated enhanced AI model with 6 degrees of freedom of head pose, and a new face model with updated blend shapes and face area partitioning. So they also have face tracking, detects human faces in images and videos, and specifies location and size of the bounding box. They have face landmark tracking up to 126 key points. It also tracks head pose and facial deformation due to head movement and expression in 3 degrees of freedom in real time. Okay, so they also have a face mesh, represents a human face as a 3D mesh with up to 3000 vertices and 6 degrees of freedom, includes 3D morphable model. Okay, body pose estimation. So there is also this article which talks about how human connection in video conferences can be improved with NVIDIA Maxine Eye Contact. Okay, so if you don't have no eye contact with the person who's speaking, still in the camera you have this AI which runs in GPUs, right? And but when it is rendered to the other person, it seems as if you are looking at the camera. Okay, that is this thing. Eye contact plays a key role in establishing social connections in face-to-face conversations. It signifies confidence, connection and attention. Continuously making eye contact is not possible in video conferencing scenarios naturally, right? It requires the user to continuously look at cameras and not at their computer displays. It can be difficult if he's reading a script or reviewing data on a computer screen. It's challenging for various physiological reasons as well. Children and adults also struggle to maintain eye contact. So to improve, augment and enhance this user experience, NVIDIA has developed this Maxine Eye Contact AI feature. This feature uses AI to apply a filter to the user's webcam feed in real time and redirects their eye gaze towards the camera as seen before. Okay, so what is the technology behind it? So this is where the eye contact pipeline comes. So you have this NVIDIA face tracking pipeline, right? So where there is an input image, face detection is done, facial landmark detection is done, head pose estimation is done. From that you get this 2D landmark and 6 degrees of freedom pose, right? So here details is given that head pose is normalized, the face in the video frame 256x64, eye patch is cropped from the frame, right? And it is fed into something called as an eye contact network. The eye contact network has a encoder decoder architecture. Encoder estimates the gaze angle from the input eye patch along with the set of features known as embeddings. Based on these embeddings, decoders perform redirection of the gaze in the input patch to make the face look forward. The last stage involves blending this eye patch into the original video frame with an inverse transformation. That is the idea over here. So you have the original image from which face detection, facial landmark detection, head pose estimation is done. Then there is this eye contact network which looks at this eye patch right? Estimates the gaze angle and then corrects the gaze angle to make it look as if he's looking in, he or she is looking into the camera, and then based on that redirection is done. So this is a complete pipeline, okay, eye contact pipeline. So this technology directs the user's gaze to the front and center, right? And then they have given more details over here about this eye contact model architecture, right? This encoder is there, decoder is there. Encoder takes the eye patch as an input, and decoder tries to redirect it to center over here. Gaze angle factor, head factor, appearance factors, these are the degree of freedom factors from the pose over here, okay. So the architecture of eye contact network transforming, okay, this is what I was talking about it. There could be also issues such as environmental lighting, shadows, white balance, hue, and okay. So yeah, representation of the following factors: subject related to skin colors, glasses, okay. So it takes into account all these factors. Additionally, predicts the state of each of these latent codified, okay. So this is about that. And based on that, this thing. So they are saying that some challenges are there for maintaining eye color. Okay. So here they say that it has been trained on a diverse dataset of 4 million images. Roughly 25% are synthetically generated to add diversity in eye color and shape. Okay. So this is some details about the reconstruction loss. I will not go into it. I'll put the link and you can read it. Okay, another one is this working range, like up to what range of so this is about redirection naturally in cone of around 20 degrees pitch and yaw angles. So if it is too much somewhere, then probably if you are looking too away from the camera or something, maybe this will not work. In a certain range it works. That is what they have told over here. And then there are things like addressing transitional drop off, like people can blink their eyes, can suddenly shift directions, right? So they say that they have taken care of that as well, okay, because typical eye motion you can move around looking at the camera, okay. This is the eye invisibility, because due to blinking your eyes may be closed at a certain point of time in the frame. So how do you take that? So what they are saying is that their pipeline is capable of detecting and preserving eye blinks. Interesting. Algorithm also turns off effect after detecting an occlusion indicated by the low confidence of landmark estimation. Okay. So what if people can, person's hand or object can block the eyes from the camera view? Yes. And they say that this is GPU accelerated using TensorRT and inference with less than 5 millisecond latency per frame. So that is what they are saying, inference happens in real time. Okay, it can work on RTX desktops, notebooks. Okay, in addition to data center use cases. So you can actually download this particular APK, try it out. Maxine, it is available. You can try out, and you can also develop these features with this particular NVIDIA Maxine SDK. So this was a short look at this eye contact feature from NVIDIA. Seems interesting, but I don't know. Sometimes maybe it may look artificial in terms of a person is constantly looking into the camera. Maybe I wouldn't want that when I'm discussing with somebody. May look a little bit not natural as well. That I'm just looking at the camera and speaking and not looking elsewhere, right? So yes, that may be a disadvantage. We don't know unless you make use of it, and when you have these conversations. You have to find out whether it's really useful that you are continuously maintaining eye contact. That's debatable. But I like this. This is quite an interesting feature. I hope you like this short video on NVIDIA Maxine Eye Contact. If you like the video, please like, share, subscribe to the channel. I'll be putting the link to this article as well as NVIDIA Maxine in the description of the video. See you in another video. Happy learning.